So let's go back to this. So today is 11.7 and our Common Core Standard. And for number sense, complex numbers 2, it says that we're going to use the relation of I squared equals -1 for addition, subtraction, multiply, and divide complex numbers. Okay, that's our Common Core Standard. Numbers, number sense, complex numbers, to use the relation of I squared equals -1 for addition, subtraction, multiply, and divide of complex numbers. Okay. All right, example 1. It's easy. Okay. Example 1, we're going to graph all 3 of these. I might use different colors for all of them, which is okay. So before I do this, let's make sure we call this axis the real axis. Okay. And this axis my imaginary. So we've got my real axis, my imaginary, and if we're just going to graph, believe it or not, this is a point. It's just a point at 1, 2, 3, 1, 2. There's point A. That's all I did. Over 3 up 2, 3, 2. Point B, 4, -2. I'll go over 1, 2, 3, 4, down 1, 2. Here's point B. Pretty easy. Point C. Oh my goodness. I made a mistake and I have to admit it on film. I did. I made mistakes, Megan. I made a mistake on film, Megan. Fix it. Alright. So let's go like this, Megan. Let's go 1, 2, 3, 4, -2, right? There's B. Thanks, Megan. All right. C is the same thing as 2 plus 0i. I'll do that one in orange. So I'd go over 1, 2, and up 0, and there's C. Pretty simple. And then D, I'll do D in green. Here we go. And that's the same as 0 plus 5i, which puts you up at 1, 2, 3, 4, 5. And there's D, okay? Alright, now, the absolute values are just simply the length from the origin. It's like Pythagorean's theorem. So it's as simple as this. We have point A, which is 3 plus 2i. To get its absolute value, we're just going to go, so absolute value of it is just the square root of 3 squared plus 2 squared. That's all we're going to do. Pythagorean's theorem. Square root of 9 plus 4, square root of 13. That's all we do. B is the same thing. If we want to take the absolute value of 4 minus 2i, that's just Pythagorean's theorem. Square root of 4 squared plus -2 squared, but please remember, when you square negative, it becomes positive. Negative times negative is positive. Don't leave this negative. It's going to really become a 16 plus 4, which is the square root of 20. Which, if we got a little fancy, is 2 square roots of 5, which I like better. Okay, you guys okay with 2 square roots of 5? Square root of 4, square root of 5, right? C. We want to find the absolute value of just 2. Well, it's really absolute value of 2 plus a 0i, which is the square root of 2 squared plus 0 squared. It's kind of exactly what I thought it would be. Square root of 2, which is just 2, because you get the square root of 4, which is just 2. Kind of saw that coming, didn't I? Square root of 2 is, absolute value 2 is just 2, right? And D, we want the absolute value of 0 plus 5i. That's really pretty easy too. It's going to be the square root of 0 squared plus 5 squared, right? We're just taking the numbers, not the I. 0 plus 25, right? Which is really the square root of 25, which is just 5. Kind of thought that was what it was going to be, right? Alright, now, on A, B, C, on example 3, I want to at least write these things down. I want to write that I is equal to the, just I. I is equal to I. Just keep I as I. I squared is negative 1. I cubed is negative I. And I to the 4th is 1. Okay, that's my little key for doing these, right? Now, here's what I know. Here's what I know. This is an important part of this, okay? Scoot over. It's a really important part of this, okay? That any time I get an I to the 4th, any I to the 4th is equal to 1. So what I need is I need I to the 4th. That's my phone. Ignore it. I need I to the 4th, okay? So when we get to D and E, I'm thinking I need I to the 4th because I need 1 times 1 times 1, right? Because 1 times 1 is just 1. But let's go back. So I to the I squared, well, we know that one. It's just negative 1. Boom. That's just given to us, right? I cubed, there it is, boom, negative 1i or negative I, boom. I to the 4th is the same thing as 1. Boom, that's easy. That's my little key. That'd be nice to have on your note card, right, when you take a quiz. That right there would be really good to have in your note card. But now I to the 12th, I don't want to keep doing this, but I do know this, that I to the 4th times I to the 4th times I to the 4th makes 12. Okay, I'm going to write it down, okay? So I went I to the 4th times I to the 4th times I to the 4th. And I want I to the 4th. I want I to the 4th for sure because that's just 1. That's just like 1. So then I've got 1 times 1 times 1. Well, the whole answer is just 1. So when I get to I to the 15th, what I need to do is get some multiple of 4. If I wrote it as I to the 12th times I to the 3rd. Okay, I'm going to stop and let you think about this. So when I get big exponents, I need something that has a perfect multiple of 4. I to the 12th can be 1, plain old 1. And then I to the 3rd, we know from our chart, is negative I. So here's the trick. You need to make sure you get some multiple of 12, perfect multiple of 12, because that's just 1 times I cubed, but I cubed from our little chart, I cubed is negative 1. So I'm going to rewrite this as just negative 1i. That's mine. Okay, you guys ready to turn it? Not too bad. All right, now, these first few are really easy. Okay, I's go with I's, real numbers go with real numbers. Okay, I'll say it again. Real numbers go with real numbers, so this is 7. Do you see it? 3 plus 4, 7. That easy. 2i minus 6i is a negative 4i. That's it. Add the real numbers with real numbers. Subtract real numbers with real numbers, okay? Number 5. Same thing. Real numbers, subtract real numbers. Imaginary, subtract imaginary. So 4 subtract 2 is 2, right? Now we got to be a little careful with our double negatives. Okay, we're going to have a double negative right here. So what I really have is a negative 3i minus minus 4i, right? Because I'm going to go with negative 3i, negative 3i, subtract a negative. But that's like a double negative, right? You guys okay if I just change that? So I really get a negative 3i plus 4i, which makes a positive 1i. So the only thing you have to be careful about is the double negatives, okay? Now, we do example 5 and 6. On my side note here, I'm going to make sure I write I squared equals negative 1. I'm going to circle that, okay? I need to know that. I squared equals negative 1. I need to know that, okay? So then, I'm going to distribute. 3i times 2 is a 6i. 3i times a negative 4i is a negative 12I squared. Oh, wait a minute. Isn't I squared equal to a negative 1? So I'm going to take this one step further. I'm going to go 6I minus 12 times a negative 1 because I squared is a negative 1. So whenever we get an I squared, we're going to change it. 6I plus 12. Side note, we always write them A plus BI. We always write them with the real, then the imaginary. So I'm just going to rewrite. I'm just going to flip-flop this around so I can go the real number 12 plus the 6I. That's the answer I want. Real plus imaginary, okay? Okay, example 6. We're going to FOIL. Keep in mind, I squared is equal to negative 1, though. In fact, I'm going to highlight that. This is, make sure you know that. I squared is negative 1, okay? So, let's distribute. 2 times 6 is 12. 2 times 2I is a positive 4I. Negative 4 times 6I is a negative 24I. Negative 4 times 2I is a negative 8I squared, okay? But I need to remember that I squared is equal to negative 1, okay? I need to remember I squared is equal to negative 1, so let me simplify a little bit further. So, I have a 12. These two terms right here can be added. It's a 4I and a minus 24I. Those two I can combine. Makes a negative 20I. I get a negative 8, but remember, I squared is negative 1. Okay? I'm going to go 12 minus 20I plus 8, because negative 8 times negative 1 is plus. Almost done. 8 and 12 makes a 20 minus a 20I. Real plus or minus my imaginary. That is my answer. Okay, we're almost done. A couple more examples, okay? Example 7. Okay? Now, real quick, back to our reading. Cannot have I in the bottom of a fraction. So what do? We multiply top and bottom by I, okay? So cannot have I on the bottom. So we're going to multiply top and bottom by I. So let's check it out. I have I on the bottom. Can't have I on the bottom. Cannot. So what I'm going to do, I know you're all paying attention. Multiply by I over I. How does that help? Well, remember, I squared is equal to negative 1. So let's see how that helps. So we're going to multiply. We're going to get a 5I over a 3I squared. Now we still have an I in the bottom, but I know that I squared is equal to negative 1. So I'm going to go, all right, 5I over 3 times negative 1, right? Which is really going to be 5I over negative 3. So what do? We basically took the problem with an I on the bottom and we changed it so the I came up on top. It's no longer in the bottom, okay? Okay, example 8 is the same thing, just a little bit bigger, that's all. So again, what do? Cannot have I in the bottom of the fraction. Can't. How do we fix it? Multiply top and bottom by I, okay? So let's multiply top and bottom by I. So I'm going to multiply it by I over I. How does that help me? Well, I'm going to distribute 4 times I makes a 4I. 2I times I makes a positive 2I squared over a 2I squared. Now, let's not forget that I squared is equal to negative 1. Okay, I want to use that information right there and right there. So I'm going to change those I squareds into negative 1. That's all I'm going to do. So I'm going to rewrite this as a 4I plus 2 times negative 1 over 2 times negative 1. Okay, now all of a sudden the I is out of the bottom. Remember we said we couldn't have an I in the denominator. We got rid of the I out of the denominator. It's gone, but we just need to simplify this, okay? So let's fix this. I'm going to have a... If I do, I'd have to cancel here. Great question. You'd have to cancel both, and you can't cancel both. So I'm going to have a 4i minus 2 over minus 2. Or now I'm going to do it to both. See how I can do it both, Megan? A negative 2i plus 1. Do you see that? Do you see the negative 2i plus 1? Or 1 minus 2i. That's what I wanted. Okay, example 9. Darn it, we need more room. I don't know if you guys are going to have to. I'm going to need more room. Okay, it's not going to fit. Forgive me. So I'm going to do it on a separate sheet of paper, okay? All right. 2 minus 3i, 3 plus 5i. Okay, so I have to change what I said. You listening? I got to change it. I didn't lie. I really didn't lie. You still cannot have an I on the bottom. Cannot. And we are going to multiply top and bottom by I, but we're going to do it a little bit differently. With this one, we're going to multiply by a thing called the conjugate. Okay, what the heck is the conjugate? Okay, we're going to multiply this thing called the conjugate. What is it? It's going to be the opposite of that. Opposite. So I'm going to multiply both top and bottom by, you ready? 3 minus 5i. We did this with square roots a long time ago. Remember how we did this with square roots? Now this is a good problem. This is a hard one. Alright, so multiply top and bottom by 3, opposite of this. It's the opposite, 3 minus 5i. So let's go ahead and do the top. Multiply 2 times 3 is 6. 2 times negative 5 is a negative 10i. Negative 3 times 3 is a negative 9i. Negative 3 times a negative 15 is a positive 15i squared. In the denominator, bottom of the fraction, 3 times 3 is 9. 3 times negative 5i makes a minus 15i. 5i times 3 is a positive 15i. 5i times negative 5i is a negative 25i squared. And Nathan's thinking, I wish I'd known this for Math is Cool competition, huh? So, that and that. I squared, right? I squared is equal to negative 1. So I'm going to fix those. So let's see what I can do. Okay, on the top part of the fraction, the numerator, I'm going to have a 6. I'll combine those and make a negative 19i plus 15 times negative 1. I squared makes negative 1, okay? These two I just added because I can, okay? On the bottom, or the denominator, one thing I see right off the bat is these two will cancel. That's why you do the conjugate. The conjugate will always cancel out the middle term, okay? So then on the bottom, or the denominator, I'll go 9 minus 25 times a negative 1. That's a big problem, huh? That's a big problem. Keep going. So, almost done though. 6 minus 19i minus 15. All I did was multiply. That's all I did this step. That's all I did is multiply these two. And on the bottom, the denominator, I have 6 plus 25 because negative times negative, okay? Almost done. It's a big problem. 6 minus 15 makes a negative 9 minus 19 over 34. Oops, I need an I there. And finally, you could leave it this way, but what we're supposed to have them as a real plus an imaginary. So the last thing I'm going to do is rewrite this as negative 9 34s minus 19 34s I. And that is the answer. That's a hard one. Is that a good extra credit problem? I don't know.